Welcome back, Wildcats. If you would, pause your video and update your table of contents. All right, now that your table of contents is updated, I want you to look at that we're on Monday, October 17th, Solve Systems of Inequalities, and that's going to be on page 22. All right, so let's go to page 22. All right, so these are the steps to graph systems of inequalities. All right, so step 1, put equations in slope-intercept form. Now, a little special note, when you multiply or divide the inequality by a negative number, the inequality symbol flips. Step 2, this is where you graph, and when you graph, if you have y less than or y greater than, it's a dashed line. If it's y less than or equal to or y greater than or equal to, it's a solid line. All right, now once you've graphed, step 3 is the shade. And then step 4 is to identify the solution. The solution is the overlapping region. Now, special note, if the regions do not overlap, then there is no solution. All right, I'm going to leave you with the question. And I want you to answer this and be ready to have your answer and attach it to your assignment, like at the back or the front or whatever, but answer this question on your assignment. When will there be an infinite solution to a system of inequalities? All right, now that you have your notes, let's go back to table of contents real quick, and let's change this to graph system of inequalities. Okay, graph. All right, so let's look at the examples. All right, remember this is on page 22. All right, so example number 1. Now, remember the number in front of x is slope, and slope is always a fraction, so we're going to put a 1 there, because remember 4 divided by 1 is still 4. But we need to be a fraction because slope is rise over run, or the change in y over change in x, so we need a numerator and denominator. All right, so to graph this, we first notice that it's in slope-intercept form, so we can move on to step 2, which is graph. So we start at 0, -4, and we see that our slope is 4 over 1. So we rise 4, so 1, 2, 3, 4, and we go to the right one. And we go 1, 2, 3, 4, go to the right one. At this point, you're probably going to need to grab a ruler, and that's what I'm going to do. All right, now that you and I both have a ruler, we see that there's no line underneath, so it's a dashed line. And I want you to draw your line extending past the graph, and I'll explain that in a second. All right, so that we see it's greater than, so we shade above, and I want you to actually shade outside of the graph, because remember, this graph extends past the graph. All right, now let's graph the second line. Now we notice the second line, again, is in slope-intercept form. I'm going to put a 1 in front of the x and a 1, so we can identify slope. So then we start at -3. And in this case, the slope is -1 divided by 1, so we go down 1 to the right one, down 1 to the right one. Now, it has a line underneath, so it's a solid line. Again, I want you to purposely draw your line extending past the graph. Now, we see that it's greater than, so we shade above. So you're going to darken the overlapping region. And I want you to go past the graph because I want you to realize that all the solutions past the graph, it's everything that overlaps, and it overlaps here. All right, so your solution, we look at in step 4, is this region because this is the overlapping region. All right, let's look at example 3. All right, now you notice in example 3, it's not in standard form, so we need to solve for y and put it in standard form. So to put this in standard form, we're going to subtract 2x from both sides. So you get negative 3y less than or equal to negative 6 minus 2x. And then we're going to divide everything by negative 3. But remember the special note, when you divide or multiply by negative, the inequality flips. So you get y greater than or equal to 2 plus 2/3 x. All right, so let's graph. So we start at positive 2, and our slope is 2/3, so we go up 2, 1, 2, to the right, 3. And there's a line underneath, so it's a solid line. And we see it's greater than, so we shade above. And again, purposely shade past the graph. All right, so we notice the second equation isn't in standard form. So we're going to solve for y and put it in standard form. So we subtract 4x from both sides, so we get negative 6y greater than 6 minus 4x. All right, and we divide by negative 6. And again, that's a special case. When you divide by negative, the inequality flips. So you get y less than negative 1 plus 4 divided by 6x. Now, whenever you can, you want to reduce the fraction. And we know that 2 goes into 4 2 times and 2 goes into 6 3 times. So 4/6 actually reduces to be 2/3. All right, so to graph, we start at negative 1. And in this case, we go up 2, to the right 3. So 1, 2, 1, 2, 3. Now, we know there's no line, so we know it's a dashed line. And since it's less than, we shade below. All right. So in step 4, a special note says if the regions do not overlap, then there is no solution. So the regions don't overlap, so there's no solution. All right, let's look at one more example. Let's look at example 5. All right, so we notice the first equation is standard form. And you can put, if you want, plus 0 here, so it's really in standard form, but we know it's basically y greater than x, so that we know when x is 1, y is 1, when x is 2, y is 2, when x is 3, y is 3, when x is 4, y is 4. Now, there's no line underneath, or there's a line underneath, so we know it's a solid line. And we see it's greater than, so we're going to shade above. Now, you'll notice that I'm shading light, and the reason I do that is because I'm only going to shade dark when we do the overlapping region. All right, the next equation, again, is in standard form. We'll put a 1 in front of the x. So we have our slope. So we start at 5. So 1, 2, 3, 4, 5. And we need to go up 1. Well, we can't do that, but we can do the opposite, which would be down 1 to the right 1. Or left 1, down 1 to left 1. Down 1 to left 1. Down 1 to left 1, down 1 to left 1, down 1 to left 1. And the reason why I can do that is because negative 1 divided by negative 1 is still a positive 1. But we have, now if I include the negatives, I can go down 1 to left 1. All right, again, there's a line in it, so it's a solid line. and it's less than or equal to, so we shade below. And I'm going to kind of darken, and not much because I still have more to go, but that's where we're at so far. And it actually goes below there. But so far, that's the only overlapping region. Now we have y less than or equal to 5. Well, that's a horizontal line at 5. And it's less than, so we shade below. And again, the only overlapping region is this region right here so far. All right. Now we have x is greater than or equal to negative 2. So that's vertical line at x is negative 2. And it's greater than, so we go here. But again, the only shaded overlapping region is this region right here. So your solution is this overlapping region. All right. So I'm hoping you're having fun. This is one of the funnest things to do in math. You get to do math, you get to do coloring, you do lines. I mean, it doesn't get any better than this. So I understand if you want to keep going, because I mean, honestly, this is more fun than anything you could be doing right now. So, but if not, I'm going to go over example 2, 4, and 6 and any questions from the assignment in class. So I'd like y'all to have a very colorful Wildcat day.